I'm Yolande Poirier from Oracle Technology Network, and I'm here today with Michael Hoffer. Michael, hi.
Hi.
So, Michael, you are working at a research center. Tell us about it.
Yeah, so we are doing research. We do simulation software for different applications like technological simulations and medical simulations and stuff like that. And we write numerical software for that in C++ and Java. Yeah.
And so you build also a simulation software for 3D printing.
Yes, right. It's a visual programming environment. Actually, it's a general purpose environment. So you can just program any type of Java and Groovy application you like. And you can combine it with visual programming. And yeah.
Should we so you want to do a demo as well, right?
Yeah,
okay,
right.
So let's look at it then.
Mm-hmm. So first of all, I'll show the basics. So the software is called VRL Studio, and it's freely available. It's open source. And I just explain the basics, and then we go into the 3D printing stuff. So what you can see here is a very simple Groovy class. It has just one method, hello world. And we can directly compile that from this environment. Mm-hmm. And when we do that, we can create an instance, and we get a visual instance of that source code. So we write source code and get a UI for that. So that's the basic concept. So you can just, without restarting the application, write small snippets and then connect them graphically. And let's try another one. Like in this case, we add two integers, integer a and b, and we return the result. And the very cool thing is that also for this one, we get a nice interface. So this here is the interface for this source code. Mm-hmm. And now I can just type 2 plus 3, for example, and it gives me the result 5. And I can connect those, can create another one, and declare a data dependency between them, like this. And I can hit invoke again, and I get another result. And also the environment does a validation. So if I type something wrong, like 2a, which is not an integer, and I click invoke, then I get appropriate error messages. That we can't see that now, but it just gives us an error message that says this is an invalid data. So now it works again.
So when people download your software, do they also get like examples of
they get examples,
shapes and
there is this basic instructions for how to visually program. Mm-hmm. So like I showed here. There are also some examples here, like a 3D geometry sample. So what we do here is we define nodes in space, and we define a triangulation, and then we just return a geometry. So let me scroll down a bit. So here you see vGeometry 3D object. Yep. If I compile that one, it works just like the other example. In this case, we get 3D visualization. Okay, don't know why we see that one. But then we try the other one that already works. Must be because of the second monitor or something.
Right.
So let me close those here. But we also have a navigator. We can just browse components. Mm. And in this case, we are now going to look at the JCSG library, which is just an ordinary Java library. It also has interfaces for JavaFX and Swing. And now we design a 3D geometry. So in this case, we have a cylinder, and now we have a second cylinder. We can define the resolution of the cylinder and radius and so on. And then we create a custom one. And this is special again. You can just write the source code, which is really minimalistic, and then you get an interactive visualization. So you see it here.
So you can change the...
Yeah. You can change the view and debug it, so you visually see the result of the computation here.
So the last one was actually something that was also pre-coded, or it was available as a sample?
It's available as a sample, right? So the whole thing is available as a sample. I created it at the last DevOps conference in Belgium. And so now let's expand the other one. So here we build the difference between the first cylinder, between this one. So I select it, it's blue now. And these circles. And the difference is this. We build a circular structure out of small cylinders, and then we can print that. And if we only print the boundary, then we have a bracelet or something like that. So, and yeah, that's the software. It's completely open source. Just Google for VRL Studio, and you will find it. And yeah, it's based on Java and Swing, and also partly on JavaFX now. So we are converting it. Yeah.
And so you build a little holder or robot. Can you show us the robot? I can hold it here in the middle.
We can switch.
Sorry. Here. Switch the camera, and then I can hold it.
Yeah.
So tell us about what
this is a Raspberry Pi and 2 servo motors, and then just a small breadboard on top.
Okay.
And this is a completely functional robot. And all the connecting parts are printed on an Ultimaker 3D printer. And you can also code and design all these parts, like the wheels, for example, in Java. And we also have either the VRL Studio for general purpose programming, or JFX-Get, which is a smaller application that lets you do this in Groovy code. And then you can just print replacement parts or bigger wheels or something. You can just customize it. And there was also a presentation at Java 1. And there we have some schematics and demo code. And also Java code that runs on the Raspberry Pi to control the robot. So you can control it from this Pi on Wheels software. And yeah, then you can build small robot armies and control them from Groovy or Java.
So I'm pulling it apart because the fascinating thing is that you actually printed those the holders, right?
Yeah, here are the holders. We can also take that apart. Just a very small piece. It's easy to code, just a few lines of code, and you can completely customize it, like the spacing here. If you have a different board, like a new Raspberry Pi 2, maybe you changed a little, or you just want a different shape. And also the connecting parts for...
I'm holding this part.
Yeah, I take the servo out. You see here, we also have this white servo holder. And it fits very nicely, so it's difficult to take it apart. It's like this.
Yeah, so really simple parts that just enables you to assemble this, right?
Yeah, so if you
another one here.
Do this at school, for example, or university, of course, you have to buy one 3D printer, but then it's only just Raspberry Pi and a few other parts. So the robot is very, very cheap, like a tenth of most of the other robot projects, like Lego or Mindstorm or something. And you can do amazing things with it. So you can do Java programming on it, and also other languages, and yeah, it's really fun.
And so on your wheel, you actually have also a little motor, right, to action the wheels.
Yeah,
right?
that's a standard servo motor from model makers. You can just buy it online, and I changed it to support full motion, because usually it stops after some degree, and it's just for rudders or something. But I made a continuously moving device out of it, so it's a very cheap motor, like $5 or something. So really cheap, and you can control it from the Raspberry Pi and set up different speeds and directions.
That's awesome. So cheap, easy and programmable, changeable.
And all open source.
Yeah, open source. So it's excellent. Thank you so much
Cool.
for talking to us and for showing us your project.
Thanks.
Thanks you.